Welcome, Tiny Hands Big Dreams, here on the homestead in southern Ecuador. We have a huge problem. So our lovely solar system out there mostly has done great. Started to have a weird problem. We have a battery failure, and it's progressively getting worse. We have the battery is made up of cells, and one individual cell is going south. Really concerned about that. So we have one cell that's going really high, and then it fills up before the rest because it doesn't have the capacity, and then that same cell, when the battery is draining, falls off first, triggers the battery low cutout, and then again shuts off the battery. It's a nightmare. This is like when you're off grid, like this is number one nightmare. This is what you worry about, is something like this. So let me go show you what it's doing, and then we're going to dig into it and see if we can figure it out. I hope we can, because like I have a couple of spares that I brought with me, but otherwise there's no answer. There's no replacement cells. They only come from China, and they're really hard to get. Let's go see. All right, in the belly of the beast, the old Victron, doing a good job. However, when we look at our controller, we see that it is terrible. Basically, if we watch, we're going to see the individual cells, and they're terrible. On the low end of the charge, they're very low. On the high end of the charge, it's high first. This is a failure. So we now have to dig into the battery pack and maybe change a cell. So we got to go look at that. So first thing is I'm going to go grab my spares that are actually doing double duty as a pig nightlight. So let's get that. And the pig nightlight. This is the most ridiculous nightlight ever. There are two giant lithium ion cells in here that runs these few tiny LEDs. I think we calculated like 4 to 6 months. I've tested the voltage even after 2 months, and it's identical. So yeah. Now, this is my two spare cells that I need for the house battery. So I'm going to open this up and pull these out, because I filled this charge up. The only time you can switch batteries as at full charge state, it's the only time you know. Otherwise, you could put in one at 50% and one at 90%, and the voltages are identical. This is a problem. So let's get it open. So I did a whole video on the construction of this box. And at the time, we had a trail cam mounted here, which was the kids, and we were using this as a super long life waterproof trail cam housing, and the trail cam would last, I mean, gosh, forever on it. So that's what this is, and if you want a full in-depth video, go check that out. So let's see, I have a ton of screws here. Let's knock it down. And there we go. Gianty batteries. The bag is because in case there's a flood, water can get all the way up to the top and really shouldn't get in. This lives literally out in the jungle in the Amazon. And so far, everything is beautiful and dry and clean. There's always the underdog. So that's what these cells are. Now, at first glance, it looks fine. Then I pull that out, and I see this one. Oh, crap sauce. This is what you call a swollen cell. This is super double mega crap. This is like when you're out in a canoe and the person you're with loses the oar overboard, and you're like, cool, we have a spare, and then you find out your spare oar is broken because somebody used it to lever rocks last summer, and you don't have a spare. This is I cannot put this back in the pack. It is badly swollen. This one, This one's fine. That's the way it's supposed to be. Oh, crap sauce. So, yeah, I don't have a spare pair. I have a spare battery. Crap sauce. Let's go check out the pack. Maybe we get lucky. All right. So the old battery box thing that I made myself. Back when we built this, the built boxes were actually, they were selling at a huge premium. I opted to just buy the raw cells and build my own. Some basic stuff on the front. There's an on-off switch, master switch. I have a giant fuse. I have a shunt for PV in and output. And then, hard to see down here, I have a resistor. And that's actually a startup resistor. Because I have two positions on this, the first position charges the inverter through the startup resistor. This stops me flipping it over and it drawing a huge inrush surge and basically an arc on the switch. And then once the capacitors and the inverter come up, then I click it over to the other position, which is now directly connected to the batteries rather than connected through the resistor. Simple trick, solves a problem. It was like a $4 fix. Lovely golden oak. All right. Here is the old battery. Now, you can see all the cells in here. I'll gently peel this back. Now what we're looking at is, these are the individual cells. These are bus bars. They're in pairs. So this pair of cells then feeds into this pair of cells. So I have 16 cells, but they're paired together, so it acts as 8 double-sized cells. Now, unfortunately, the way this box is built, this side is the one that comes off, and it unbolts off the back. There's a ton of bolts. It's actually holding all of these cells in compression, as per manufacturer. So that has to come off. All the bus bars have to come off. These little wires are voltage sensing and cell balancing. And that goes to the battery management controller. And slightly controversial. I'm going to move that just because I keep bumping it with my shirt. Slightly controversial, what I've done here on these wires is I have soldered them. So there's big discussions on the forums about how to attach those, and many people went with crimps or ferrules, certain kinds of crimps, and then, you know, attaching them and whole extra things. And I went, you know, everything is a point of failure unless it's solid. So I made it solid. I literally just took and soldered it right to the bus bar. I have a perfect voltage sensing without any sort of resistance loss of this bus bar, which is between these cells, so I can sense all these cells. I don't want to take this apart. Anyway, everything has to be turned off. There's a sequence to turn it off. Power off all the loads. That's first. Shut off the main switch. Turn off the BMS. And then, once that's off, then I can begin disconnecting the main leads. And then I can take off all the bus bars. Yep. All right, let's get into it. All right, so remember, this is the side that comes off, and then all the batteries come out this side. This is the bad one. Of course, it is the hardest one to get to. It's the furthest in. I don't know, I just started undoing nuts, and I go to here, and here, and here, and I got to this one, and it went, woo! Wait, what? It's finger loose. It's finger loose. Oh, snap. So I put it back down, I gave it a little torque. These are very low torque. They're rated in inch-pounds. I retightened the ones I did. I checked all the others. Every other one is perfect. That one was loose. This is my problem cell. Did I get lucky? Oh, crap. Well, let's go find out. Maybe I did. Maybe I got very lucky. Maybe the big old battery is doing good for us. Alrighty. So, I put it back together. The meter resets to 50% when that happens because it doesn't know where the charge is because I've reset the thing. It went through a full charge cycle. It was full when I disconnected it. I waited for it to end of charge, come up to full charge, turn off the charging circuits, and then I disconnected it. That means at what is now 50%, it would consider that should have been 100%. I started charging it, and it went from 50 to 76% before it end of charged. I got 26% more in my batteries than there was the last charge. That's big. That says that cell was really failing. That's this one, number 8. It's right in there now. I mean, if I look at my millivolts, this is millivolts from highest to lowest. It's nothing. It's a couple millivolts. That's fantastic. So when it gets to 100, then when it fills up, that resets this to 100. That's the only time a lithium ion knows the actual battery percentage is when it has reached full capacity. Everything else is a guess by measuring how much has left. You can't tell by the voltage. So far, I think that was it. I literally think our giant, terrible failure was really one loose nut. Wowzers. Do I feel lucky? Anyway, that's great news. We will see. I'll keep you informed, but I think that was, so far, it seems like a fix. Everything seems like it's back on schedule. Check back more for news later.